Morning, everybody. Thank you, Dick, and thank you, ARC, for providing us the opportunity to share this message with the fantastic folk that come to this ARC forum meeting. The subject of my talk is the functional characteristics of the control system that we would like to have for service in the 2020 decade and beyond. And I'm going to be reporting on work that has many contributors. Specifically, this presentation is derived from a document that was written by the list of 8 co-authors on the page here. And this activity is really led by my colleague, Steve Bitar, who's here in the audience. There's 3 parts to the talk. The first part is I want to motivate why we're working on this and motivate your attention by sharing what our business challenges is and the work that we've done to date on that. The second part of the talk is on the functional characteristics themselves, and I'm going to share just a subset of the information that we are able to articulate now regarding the functional characteristics that we're looking for. And the third part of the talk is I'm going to share what our plan of action is that really involves collaboration with many of you who are in the audience today. So here's the business challenge for us, and this is the business challenge for the downstream and chemicals business within ExxonMobil. 40% of our existing regulatory control equipment, we have to replace it by 2025. In that population of 40%, for 20% of this population, we have already set the technology basis, and we're just starting to execute the projects to do those replacements. For the remaining 80% of that 40%, the technology basis is not definitively set yet, but in practical terms, the number of degrees of freedom that we have there is constrained by the installed base of equipment that we have. So I can't give you a real crisp answer to that yet. We're still working on the details. Now, for the other 60% of equipment, we're taking a look at what we have in terms of the generation of equipment that is one generation behind currently available technology, and we're evaluating what our replacement options are for that subset of the population as well, so that we come up with a comprehensive plan for the business that addresses all these factors in a holistic way. So where we introduce new technology, I mean, clearly our primary business problem is the control replacement one, but where do we get the opportunities to introduce new technology? We're also considering new facilities construction as well. And I want to stop at this point and make a reference point to the messages that you've heard from Sandy Vassar. So Sandy's title is Manager of Instrument and Electrical. I think Sandy's other title is ARC Forum Rockstar. So, so the unique aspects of the challenge that I'm going to describe today really is this. It's two things that I want to make clear. Sandy's work is very much driven by new facilities, projects for new facilities. We have this control replacement challenge that is very much a part of the story I'm going to tell you this morning. And the other characteristic in downstream and chemicals is the relatively larger contribution to business value from advanced applications, technologies, and software. So they're the slightly unique characteristics of the business problem that I'm sharing with you today. But there are large areas of intersection between the story I'm telling you and the story that you'll hear from Sandy. We have learned an enormous amount from Sandy's team. We share our ideas with our colleagues in upstream. And so there's a very large area of intersection here between the messages that you're hearing from ExxonMobil. Okay, so we started a research activity about 4 years ago that was given the following objectives from senior management. Reduce the cost to replace our systems. With the systems that you install, enable the delivery of more business value from the control system compared to what we're getting today, and also do what you can to contribute to the competitiveness of our existing or brownfield facilities versus the new plants that are being built around the globe. So this is the threefold objective function, if you will, for the research project that I'm going to describe. So where are we in this journey? So I've already said we're about 4 years in. So in addition to this very forward-looking research, which is really what I'm going to describe today, we are doing what we've done for a long time in parallel, working on more traditional measures to extend the life of equipment that we have. So these activities are running in parallel in our company right now. But focusing on the research project that I really want to describe today, one of the things that we have delivered in 2014 work products is a set of documents that really describe these functional characteristics, and we've written them in several parts just for manageability, examples being a business case for action and the core characteristics, which is really the material that I'm drawing from for this talk today. The objectives that we have for writing these documents is to really motivate discussions between ourselves and prospective suppliers. We want to be as clear as we can, stating what we want, not how to deliver what we want, but simply stating what we want. Okay, the second objective is to help us by providing a reference to help us assess the supplier's roadmaps. And then the third objective for producing these documents is to help us in discussions identify opportunities or needs for technology development. So that's the purpose for us writing these documents. Okay, let me switch to part 2 of the talk right now, and again, it's the introduction of the functional characteristics. So the functional characteristics set that we have, there's 27 of them. Each one of them is roughly a short paragraph. And Dick was extremely relieved when I told him I was not going to read all 27 paragraphs from the podium. So the intent is really just to share examples with you. But after the team wrote these characteristics, we took a step back, looked for patterns and themes, and we can articulate 4 themes in the set of the 27 functional characteristics. So I want to introduce them to you, starting from the 4 themes. So theme number 1 is distributed modular architecture. Steve is toying with maybe we retitle this to distributed modular platform. Be that as it may. And I'd like to map each theme to a set of business goals to clarify mechanisms of value that we're going after with each of these themes. So in this first one, it's to reduce the cost and risk of I/O controller and HMI replacement, reduce the incremental cost that we incur when we add more control capacity to a system. And the third business goal that's associated with this theme is to enable us to increase the value from the process control system by letting us incorporate new functionality on process while the plant is running. So I'll have a 1-page example of the subset of the characteristics for each of these themes. The second of the themes is interoperable open architecture. Our business goals here are to reduce our costs by enabling application software reuse. A big percentage of the cost of these replacement projects is rewriting the application software. It's not the cost of the hardware. And this is what we're going after with this set of characteristics. And I'll foreshadow a little bit. The discussion that was held in the panel discussion this morning is one that we're very much interested in pursuing, increased value by enabling a commercial market for applications software. It's something that we see a lot of potential value for, and I'll make some clarifying remarks as I wrap up this talk on that point. As a sign of the times, our third theme, we gave it the title Intrinsic Security. The business goal there is to protect our operations integrity and information. And again, I'll speak in more detail on the slide later in the talk. And the fourth theme, kind of a catch-all, but very all-encompassing, help us reduce complexity and improve the productivity of our engineering talent. The business goals there are the very high-level ones of process control. So reduce the capital costs that we incur during the design and build phase of the life cycle of a plant, and also the replace phase of a control system. The set of characteristics under that theme are also going after the help us increase value and reduce operating expense during the operate and maintain mode. So this is an overview of the 27 functional characteristics. Let me give you the example set for the distributed modular architecture. So the system must interface with existing field devices and wiring and should accommodate all external network communications interfaces. Pretty simple statement, okay? Again, in the paper, there's more details. The second example here should be very familiar. Dick did a good job of introducing it, but I want to go beyond it. Specification of the connection between any I/O and any data consumer and producer should be configurable, should have the attributes of dynamic and late binding. But I don't want to leave it there, and I'm not going to go into too much detail right now, but we have articulated characteristics and some supporting information that help us address the control system replacement challenge that we want to do on process while the plant is running, that's related to the functional characteristics of the I/O to the controller interface. So the point of this small elaboration is our thinking here goes a little bit beyond the message that you've heard from Sandy and what was reinforced by Dick a few minutes ago. The third of the sample characteristics in this theme, I/O module, controller, or HMI addition or replacement should be achievable on process with the characteristics of a maintenance activity. Okay, right now, these are enormous projects that we have to get into to do these control systems replacements. And we'd like to get ourselves to the world where it's not such a big deal. It doesn't require so much engineering, and it's actually would be conceivable for my company to do these during maintenance turnarounds as opposed to doing them on process. Okay, that's a big challenge for us. Okay, I'm including references just to substantiate what we've documented in our report, but I'm not going to go into the details on references in this session right now. Okay, the second theme where I want to share some examples of characteristics is the interoperable open architecture theme. Pretty high-level statement here, the first characteristic. The system must use an open, interoperable, industry-standard network protocol that supports both communications and distributed control. Second example characteristic. Not example, this is just an illustrative subset from the full document. Function block control strategies should be exportable and importable using industry standard formats, directly attacking the software portability attribute that we're seeking. And this is a build on the point that Dick mentioned in his remarks. The system enables integration of user and third-party applications so that they can operate equivalently with respect to function and performance as the intrinsic functions of the system. This is what we're looking for. Okay? Now, there's been a lot of discussion about openness, right? You guys have heard about this for a long time. Okay, this is not our first rodeo, and I want to give some hard evidence to support the hypothesis that openness and interoperability are feasible in a control system that has safety criticality requirements and hard real-time determinism requirements. And the example that I want to cite is some very interesting work that we're watching in the avionics industry in the form of a consortium that has the title, the Future Airborne Capability Environment, acronym FACE, the FACE Consortium. So FACE is a US government industry partnership that is defining an open avionics environment applicable for all military airborne platforms. This activity is moving very quickly. It was founded in 2010. Its work product is an open architecture that enables rapid deployment and reuse of software across these military airborne platforms, military aircraft. It's not just technical work. One of the first things that this consortium did is it sat down and looked at what are the incentives for the participants that would bring them to the table. So there's a whole body of thinking and documents in this consortium about what are the business guide, how does everybody win by participating in this consortium and abiding by these standards. There are the architecture and technical standards themselves, and there's a figure here that I'm not going to go into that's their kind of like the picture that is the 1,000 words behind the architecture and the technology. They also, at the beginning, at the founding of this consortium, they also built a compliance certification procedure and means to do so. So the status of this activity is, so the US Navy is the the biggest user of this. So contracts are already being awarded requiring compliance with the FACE standards, and devices are being built that satisfy, again, the technical requirements of the FACE standards. And it's extremely intriguing to us, again, as hard evidence to support open interoperability and the rigorous services that we require. There are a lot of participants in this consortium. My last count from looking at their website, 78 companies are involved in this activity at varying degrees of, I guess, financial contribution to the activity. So again, we derive a lot of encouragement, if you will, from this activity, and arguably there's perhaps usable technology for us as well. Okay, back to the functional characteristics introduction. The third theme is intrinsic security. The system must provide authentication mechanisms for devices and users that comply with industry standards for integration and operational assurance, and that allow for flexible and easy to administer role-based access. Systems should have the means to track communication patterns, including systems, network, and applications behavior, and issue warnings when deviations from normal occurred. It's very interesting during the executive panel discussion this morning, this exact characteristic was described by one of the panelists. I want to elaborate on this page a little bit. So my colleague Johan Nye, in our review of this document, asked me, said, Don, I want you to make a statement that systems shall comply with IEC 62443 and comply with ISA Secure. So I pushed back. I accepted essentially all of Johan's requests for change, but on this one I pushed back because at this point in time with this document, we have not written any hard requirements to use specific standards, rather. But I was talking with Larry O'Brien yesterday. I envision as we do work on this activity, we're going to get to the point where we're going to be making fairly hard statements about specific standards, but we're not there yet. Okay, we want to work into this by dialogue. Okay, finally, to give you an example of characteristics from the fourth theme of remove complexity and improve productivity. The system should provide a human-machine interface that integrates data from any source in the system and presents it in a manner independent of the source of the information. A build on that idea, we would like to see the system provide a common configuration or programming environment for all software components of the system, acknowledging that some of those components are going to come from third parties. Again, in the remove complexity, help improve the productivity of our engineers in using these systems. And the last example characteristic that I'll share before I move into my concluding remarks, systems should provide means for interoperable exchange of structured and unstructured data among operations-level applications and between operations and business computing systems. So this completes the illustrative examples of the functional characteristics that we're asking for as best we can articulate at this point in time. So to give you a sense of the big picture here, I just have a few bullet points that are, the intent is to span the space of the functional characteristics that we're asking for. So this is some reinforcement of things I've already said, some new business. The system should enable interfaces with existing devices and wiring and support the continuing evolution of digital devices. One broad theme. Shall be continually upgraded, or upgradable is perhaps a better way of saying that, without requiring wholesale replacement. So let me just elaborate on this point a little bit. So we've taken a look at the kind of the three-part monolith structure that we have of I/O, controller, and HMI, and we're challenging where some of those interfaces are drawn to help us address this characteristic about upgradability without wholesale replacement. Another one, the system should have the characteristics that help us to preserve the asset owner's intellectual property. It's this whole business of portability of software applications. Again, the next one, intrinsic security, has received a lot of discussion at this conference already. We wrote this down quite some time ago. Security needs to be designed and built in, not bolted on. In terms of new functionality of the control system beyond what DCSs were originally built for, we'd like to see intrinsic characteristics that help us improve the situational awareness of our operators. And again, a little bit off the page here, but I want to make the point that's strongly made in the document. We'd also like to see a better integration of math algorithm-based controls as well as sequential logic to solve the whole task of automating and controlling our processes. It's a build on this theme summary. The system shall not be limited to the control capability provided by the supplier's function blocks. And building on that notion here, we'd like to have a platform that enables innovation via software. When I take a retrospective over the last couple of decades, the majority of the value-adding applications technologies that we use have entered at the level 3, the manufacturing execution level, right? So why is that? That's because the technology providers could deliver solutions there that they couldn't deliver in historically what had been the DCS. That's a characteristic that we would like to challenge. Why is that? Does it have to be that way? We understand the security, the availability requirements, but does it have to be that way? Okay, concluding remarks. So where we are in our process right now, this document that I'm referring to, functional characteristics, it is not a specification. Okay, we have not made any statements about certain must-have features that are available in current systems that will be required going forward. Okay, and just to not be silent on some very fundamental principles. Okay, the system that we want must be safe, must be reliable, must be secure. So our intent as an asset owner is simply to describe what we want, not how to do it. Now, we couldn't resist the temptation of making some comments on how. It helps clarify the ideas, but clearly our intent is just to simply describe what and draw on the creativity of the supplier community to deliver. A couple of credo statements here. We believe that there are few, if any, undiscovered technologies required to satisfy functional requirements. Instead, we think, integration of existing technologies based on existing standards is really what's required to get us most of the way there. A second we believe statement. We believe there are win-win incentives here for both asset owners and suppliers, and these incentives will be in the form of permanent elimination of systemic life cycle costs. Again, this is directly attacking the control replacement problem. We see opportunities to increase the value derived from the control system, and specifically speaking to the perspective of the supplier, we think that embracing these functional characteristics will increase the capability of what we can do with the control systems. That expands the addressable market and the revenues from your side of the ledger. Here's what our plan is going forward. It is our intent. We are going to publish the functional characteristics documents to satisfy my company's requirements of what we want to do with respect to competition law. We will have clarification meetings with suppliers that would like to spend the time to talk with us. Either during those meetings or separately, we want to make sure that we understand roadmaps, and we want to explore, technology development needs or opportunities as we march further into this plan of action. And finally, on a plan for success basis, we envision, working at some point to develop processes for business case alignment and get to the hard tasks of industry standard selection. And now, what I didn't write down on this page, but if you're taking notes, we have a finite window of opportunity here to satisfy our near-term challenges on the control systems replacements. The clearest statement of a date that I can articulate is that we need to define the technology basis for our next wave of replacement projects in the fourth quarter of 2017. It doesn't mean we have to have fully working solutions by that time, but we need, for the purposes of planning these projects, we need to have a reasonably high confidence picture of what our technology basis is going to be going forward. So what I've tried to do in this talk is to share with you what our business challenges are, and clearly ExxonMobil alone can't provide the solutions to meet those challenges, okay? We need the creativity of many of you in the room and the technology supplier community to help us address those challenges. Thank you very much.